Good morning, everyone. Today we're going to learn about a two-way table. In this two-way table, you'll learn how to construct, interpret, and justify a relationship between two quantities. The learning objective you'll be using through the lesson. We'll go through it when we need it. So let's start with interpreting a two-way table. A two-way table displays two categories of data collected from the same source. If you can see, there's columns that talks about the students who studied or did not study, and the rows talks about the grades, whether they passed or failed. So those numbers inside the table are joined frequency because it joins both category, whether they studied in past, studied and failed, did not study and passed, did not study and failed. The one joint frequency is 1, which represents the number of students who studied and failed. Now it's your turn. Marginal frequency. The sums of the rows and columns in a two-way table are called marginal frequency. If I add up all the rows, it gives me the total number of people who passed the test. So 21 plus 2 is 23. 1 plus 6 is 7. And then the number of people who did not study are 8. The number of people who studied are 22. And then at the end, you have this total number, which has to add up those column, and this row has to add up to that exact number because that is the total number surveyed, which is 30. So 23 plus 7 is 30. 22 plus 8 is 30, and that's how I know I did my math right. Because the total number are 30 students who were surveyed. So one marginal frequency, for example, is 22, which represents the total number of students who studied. Now, how do we construct a two-way table? You randomly surveyed students between the age of 12 and 17 about whether they ride the bus to school. The results are shown in the tally marks. Make a two-way table that includes the marginal frequency. Now, look at the tally marks. We should have two categories. The first category, whether they ride the bus or not riding the bus, and those are going to be the rows. And the second category will be the age. And the subcategory under the age are the age groups, which 3 of them, 3 subcategories under the age. Then we count all these tally marks and put them in the table. And since they need the marginal frequency, that means I need to add the total column and row. So the first category is age, and the subcategories are the age group. The second category is the number of students who ride the bus or does not ride the bus. All these numbers are joint frequencies. All these numbers are marginal frequency. Finding a relationship in a two-way table. After finishing constructing a two-way table, how can I justify if there is a relationship between the age and the number of students who ride the bus or does not ride the bus? Does the age matter? So for you to do that, you have to find the percentage for each subcategory. To determine whether the relationship exists between two quantities organized in a two-way table, you have to find the percentage of each subcategory. So the subcategories are here. So for example, 16 to 17, who rides the bus? What percentage of students rides the bus age 16 to 17? And the way to do that is follow this equation. Percentage equal the part you're asking for divided by the total of subcategory times 100. So for you to find the percentage of students age 16 to 17 riding the bus, you take the 14 divided by the total 35, gives you 0.4, and then multiply it by 100, gives you 40%. So the number here is 40%. Now it's your turn to find the percentage of all other categories to see and justify if there is a relationship. Does the table in part A show a relationship between age and whether students ride the bus to school. So here's the table with only the percentage to explain if the age of 16 to 17, which is the older kids, do they more likely ride the bus or do not ride the bus? Since the percentage is 60%, which is higher than the people who ride the bus. So the older the kids are, the more likely they do not ride the bus. The younger students, more likely they ride the bus. As a conclusion, here's the relationship that I can find. The table shows that as age increases, students are less likely to ride the bus to school. That's it for today's lesson. You were able to construct a two-way table using data from a survey. Make sure you know what the categories and the subcategories are. Interpret joint frequencies, which are the numbers inside the table. Interpret marginal frequency, which is the total numbers, columns or rows. Justify whether a relationship exists between two quantities. At the end, you have to find the percentage to see if there is a relationship between the two quantities, whatever they in the context of that problem or in a two-way table. The higher the percentage, the more likely the event will happen. That's it for today. Thank you and see you next time.